necessarily, but this was stuff that was on the quiz last week. So what are we going to do? We can do that. Absolutely, we could find x by intercepts. Totally fine. They do want us to solve this in a slope-intercept form, though. They say solve it in a slope-intercept form. So since we have to solve it in a slope-intercept form anyway, we can graph it from that. I wanted to practice an important piece on this one. So if we want to solve it into slope-intercept form, that means I need to get what letter all by itself? Y. I need it to be a y equals, or in this case a y, and then some inequality sign. We just don't know which one yet. So what am I going to do in order to get the y by itself here? Well, I mean, you could add the 4y, but that's not really going to make things be by themselves. Let's subtract the 2x. I want to get this guy all by himself. That's an x. I'm subtracting 2x from both sides. Then we have minus 4y, do not drop that minus sign, is less than, can I combine those together? So I'm going to put them next to each other, and since we usually like to have mx plus b in that order, I'm going to put the minus 2x in front. So I'm going to have my minus 2x plus 8, because it's a positive 8. Thank you. Oh, you really have to do this period. All right, I still want to get that y by itself. So what do I need to do?
Add 4.
Not add 4. What is happening between the negative 4 and the y? We need to divide because they're currently being multiplied. So I need to divide this thing by negative 4, which means I need to divide this thing by negative 4, and I need to divide this thing by negative 4. When we multiply or divide by a negative number, what happens to my inequality? We talked about it briefly. What happens to my inequality when we multiply or divide by a negative number? It flips. It changes direction. When you multiply or divide by a negative number, your inequality sign changes directions. So my negative 4 and my negative 4 cancel out, and we're left with y. This guy is going to flip around and face that way. Negative 2 over negative 4. What does that simplify down to be? Negative 2 divided by negative 4. What's that going to simplify down? Positive 1/2. Because those two negatives cancel out. So we have positive 1/2 x. 8 divided by negative 4? Negative 2. Just commit. So you can still solve these in a slope-intercept form, even if they're inequalities. We just got to be careful about that negative sign. Other than that, the process is exactly the same. So when we go to graph this, where am I going to start? Negative 2, more specifically. The y-intercept, that's negative 2. So it's the point 0, negative 2. So it's down here. Up 1 over 2. Are we going to connect these up using a dotted line or a dashed line?
Dotted.
Or I meant dotted or solid, but yes. Solid is when it has an equals to underneath. So since this does not have an equals to underneath, we're connecting it up with a dotted line. So we're going to use a ruler. I put all our rulers back out because our new janitorial staff is awesome, if overly helpful. Because I wind up with my rulers all on my desk. But that's okay. I would rather that than them not actually being in here and doing stuff. And I don't know where my ruler went. So I have the wonkiest of lines. I was going to say, when we say that I can tell that you did not use a ruler,
Yes,
we can tell when we don't use rulers. Yes, I can tell.
She did
Uh-huh.
put that on
You
one.
gotta use rulers. Gotta use rulers. It is not optional when you are graphic lines. There we go. I find something. Oh, that's the next one. All right, we still have one more step to go. Because my inequalities, I need to do some shading on. And you can use either our original inequality for the test, or you can use our new one for the test. It does not matter which one we use. What's that? Oh, you're right. It is supposed to be a dashed line. Luckily, I happened to find my ruler anyway. So, dashed line. We even talked about it right before I started drawing it. Then I got distracted by the rulers. Boop, boop. Exhibit A of why we use pencil. Because if I had done that and I was using a pen that I couldn't erase, I would have to go in like white out things. All right, so we need to test a point to figure out where we are going to be shading. What point do we want to use as our tester? 0, 0 is an easy one to use, and it's not on my line, so it's a valid test point. So we're going to test the point 0, 0.
We're not done.
Not done. We got to color it. Whenever we have an inequality, a less than, greater than, less than, equal to, greater than, or equal to, we have to color it. Do not color on the ones that are just equals. Now what we do? All right. We can use either equation and should still get the same answer. So I'm going to use this one, our original. So if we have 2 times 0, substituting in our x, minus 4 times 0, and I want to know if that's less than 8. I test on this right now. 2 times 0 is going to give us what? 4 times 0 is going to give us what? 0 minus 0 is going to give us what? 0. Is 0 less than 8?
Yes.
Yes. So where are we going to shade? Above our line or below our line?
Above.
Above, because we color where it's true. Yay. So up here. Ah. There we go. Like that. Coloring things in. Okay. Questions on this one? All right, we have one section left in this chapter, and we're going to veer away from graphing very briefly before we come back to it, because the way we graphed our absolute values yesterday was fine, but a lot of work. Like, it was a lot of, like, plug and chug, labor-intensive steps. So what we're going to talk about today is the way we're going to graph pretty much everything we learned for the rest of the year, And so we're going to be introducing some pieces that are not even kidding going to come up in every chapter from here to the end. Not even kidding. So we're going to be working with something called transformation form, and right now we're going to start with some generalized transformations. But these are going to be letters we see repeatedly. And this is going to be building something we're going to call transformation form. Special functions is the title of the section that we were doing. So our piecewise functions, our absolute values, are special functions. This is going to be transformation form, which is related and makes our special functions a little less gross. So we're going to be working with a whole lot of different kinds of functions this year. Yeah. So these are what we're going to use all year. This is what we are going to be learning. I know. This is the whole year, like literally through May.
Period.
But we have A, we have H, we have K in all of however many these are. Like, I'm not even kidding when I say all year we are going to use A, H, and K. And they always have the same jobs. By the end of the year, you'll be able to graph these things. Seriously, seriously. Super impressive. Okay, but we're starting right up here. This is where we are today. A generalized form. But this is what we're doing the whole year. And oh look, we see someone very familiar right here in the middle. We have our absolute value that also uses these same letters. What? Oh my gosh, relevance. All right, so when I say we use it in every chapter, I mean we use it in every chapter. So transformation form, our kind of generalized transformation form, is when we take our f of x, that's our function, and we're going to take our a, so that letter's out in front, and it's multiplied by whatever our funky thing is for our function. It could be maybe it's just a set of parentheses. It could be that it's been squared. It could be an absolute value. It could be in a square root. It could do any number of weird things. But for our generalized one, we're just going to kind of put a parenthesis, and we're going to put our x minus h. It's always a minus sign in there. So a is multiplied by the quantity with our x minus h. And that's going to have whatever our special piece is, whether it's absolute value, if it's being squared, square rooted, whatever. This is what makes our function special. And then we're going to add k on the end. And I know we don't know what any of those things do yet. That's what we're about to talk about. So h and k are the easiest ones to do. Because h is horizontal. H is a hula. It goes left and right. So h is a horizontal shift. Which means it moves left or right. If my h is negative, it moves left. If my h is positive, it moves right. Just like on the number line. Negative numbers are to the left, positive numbers are to the right. If I'm going to subtract 2, it's going to move left 2. If I add 2, I'm going to move to the right 2. We just have to be really careful when we're pulling out our h because of that minus sign in our formula. So our h always has the opposite sign than the equation does, which we'll practice with that, I promise. I'm just pointing it out. Because that minus sign in that formula, we have to be super careful. So h is horizontal. It goes side to side, which I will wind up doing this repeatedly when we talk about h all year long. You will hula. Or I will hula at least, because I don't make you do that. Then we're going to have k. You can either think of k as a kangaroo. I feel like they travel a little too much. Or you can think of it as a kite. It goes up and down. K is a vertical shift. Is the technical name for it. So it will move up or down. And again, we move up if it's positive, down if it's negative. So if I subtract 3, the whole thing's going to go chunk, 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 and it's going to go down 3. If I add 4, I'm going to go bloop, 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 add 4, and move it up. Ooh, hello, screen. Can we not do the arguing thing again today? That would be great. Okay, so H moves us sideways, K moves us vertically. A has 2 jobs. So there's a couple of different things that A can do, and there's a few ways of writing it. So I'm going to think about parabolas. You guys talked about them at the very, very end of Algebra 1, briefly. You guys talked about factoring and stuff, looking at the U-shaped guys. So when we think of parabolas, when they're happy face, that is our normal x squared. We've worked with that before. And they're like just normal enough and happy face. If I had negative x squared, it flips upside down. The only difference between x squared and minus x squared is the minus. So it flips from happy face to frowning face. So if A is positive, things point upwards, usually. So A is positive. Is normal or standard. If A is negative, it's called reflected across the x-axis. We are going to be specific. It's not going to come into play that we have any other reflections until about March, but we're going to practice being specific so that when we need to specify, we already know which one we're working with. So as of right now, we are only going to reflect over the x-axis. We will not get to any y reflections until we get down into the these guys down here, like way at the bottom, which will be March, April, May. A has another job because we haven't talked about what numbers A can be. So it has two different things it can do. So it got a lot of stuff. So it can reflect us. Our standard form, like our normal, is that we think of it like this with a parabola, or even our absolute values that like we worked with yesterday, they look like this. If it's reflected, it's going to be upside down or a frowny face. So those would be two reflecteds. If A is bigger than 1, so the value, just the number, is bigger than 1, we call it a stretch. And what that does is it takes like my absolute value and it stretches it up really, really tall, and it gets really, really tall and skinny. So I always think of it as big numbers are big kids now, so we do yoga. And we stretch, and we get really, really tall and skinny. So if A is bigger than 1, the value of A is bigger than 1. So if it helps you, you can think about it as our absolute value of A, because we already talked about positive versus negative having a different job. So if my absolute value of A is bigger than 1, we call it a stretch. If A is smaller than 1, it's little, it's cute, it's small, it's usually a fraction. It's so little and cute, I want to squish it. We call it compressed. I will continue to say that, and you can giggle every single time if you want to. If A, absolute value of A is less than 1, it is called compressed. And I'll give us a little sketch of what that looks like here. So a stretched function for our absolute values would be like this. It's very, very squished and skinny. Whoop. Tall and skinny, and it's done its yoga because it is a big kid now. If it is small, between 0 and 1, fractions, it's so little and cute, I want to squish it. So we take our absolute value, and it looks like somebody sat on it. It goes compressed. So compressed goes out wide. Those are really hard to see on there. That's better. There we go. So compressed goes out wide, and that is true for our absolute values. That is true for parabolas. That is true for any of these funky things. Makes it really, really wide. It looks like somebody sat on it. And we are going to practice with these a bunch today, and then I'm going to show you why and how we use them to make our graphing life way, way, way more easier than the holy cow we had a lot of things that I did yesterday. Okay, so you want to have these written down. Like, again, not even kidding, we use them in every chapter. And they have the same job in every chapter. Once we learn these, they don't change. They do the same thing. This K is going to have the same job as that K, is going to have the same job as that K, so it's the same job as that K. No matter what. This H does the same thing every single time. And notice how all these H's have minus signs with them. Oh my gosh, it's like there's some consistency. What? Who cares? Okay, so like again, not kidding, this comes up a lot. So what we're going to start with is we're going to be finding these numbers. We're going to figure out what A is, what H is, what K is, and saying what they mean. Then we're going to use them. So, starting with equations. I'm giving you equations. We're going to look at these, and we're going to figure out what A is, what H is, and what K is, so that we can figure out what transformations are happening. I'm going to put our kind of generalized form at the top that we wrote on the last page. That was our f of x equals our A times whatever our special piece is, x minus h plus k. So what we're going to do is play match 'em up. So I'm going to come through here and I'm going to say, okay, what is our A value? What matches up with A on this first one over here? 1/2. So my A is 1/2. So 1/2, is that positive or negative? Positive. So it's going to be a normal, like, upright. You don't have to say anything for it, but I'm like, want us to think it. So it's going to be a normal, upright, in this case, absolute value. So it's a V. But it's little. It's so little and cute. It's 1/2. I want to squish it so much. So what do we call it when it's so little and cute? Compressed. Compressed is so little and cute, I want to squish it. I am 100% not beyond being absolutely ridiculous to get you guys to remember a weird word. As at one point, we have a strange vocab word where I will literally throw myself into a wall to prove a point. Uh-huh. But it's not till spring. It's till we get to the one that has the fractioning stuff inside it. But like, there's giggles all day that day. It's really fun though. I just have to warn my neighbor if I crash into the wall a little loud. Repeatedly. All right, so we're going to keep going and keep playing our match 'em up. I want to figure out what H is. Be careful with H. Whoop. Highlighter.
The one is positive. It's supposed to be a negative.
It's supposed to be a negative in the formula. So it's supposed to be x minus whatever my H is. So what would make a minus sign turn into a positive? Not an absolute value, because I can't change the function. If I subtract a negative number, does that turn into a positive? If we have a double negative,
Yes.
if I have x minus negative 1, would that not be the same exact thing as x plus 1? So with H, that's what I was pointing out before, but I know it's really hard to see when we're just looking theoretically. H will always, always, always have the opposite sign of our expression. It's the opposite. One of those things. Some people that helps, some people they go, what? So H is always the opposite sign of your equation. So my H value is going to be what? -1. It's always the opposite of what's inside there. So an H of -1, what way does that move us? Left. H is horizontal. Do a hula. Go side to side. Negatives are to the left. So this is going to go left 1 space. That's a 1. My L's and my 1's look identical. There we go. Just so we're clear which one's a 1 and which one's an L. Let's look at our K. What is our K value here? 4. It is added on the end. Bless us. It is allergy season, I guess, because it is just schnorky in here. So our K is 4. It's what's added on the end. K just has the normal sign that it has. What does K do transformations-wise? It's the vertical stuff. So if I have a positive 4, which way are we going to go? Up. So this is going to go up 4. Okay? Questions on that one? That is all we're doing with these for right now. Notice the for now. Okay. We're going to practice this again. We're going to practice this a couple more times before we actually do anything with it. Giving us a little barrier here. So looking at our right equation, I've got my f of x equals 3 parentheses x minus 4 plus 1. So what is my a? 3. Sometimes I just wait for more than one person to say it. Which means, what is that going to do to my graph? What does an a of 3 do? Stretch. It's a big kid, does big kid yoga. It stretches.
What did that say? Equals 1/2?
That's a equals 1/2 compressed. A lot of times with the transformations, I'll write my a's like that because otherwise my a's start to look like 9s. What is our h on this one?
Negative.
Ooh, careful, careful, careful.
Positive, but you always said.
Is the opposite of the sign. So what is our h? Positive 4. Our formula has a minus sign in it, so wrong color. Ignore that minus sign there. It's just the positive 4. That is the trickiest part with h, is it always has that opposite sign. So if my h is positive 4, which direction do we go? Right. So this is going to go right 4. What is our k? Which means what way does it go? Up. This is going to go up 1. Okay. We're going to practice another pair of these before I show you why we care. And how this helps us with the holy cow too many plug and chugs that we had yesterday. We're going to do one more pair. I've got f of x is negative 1/4 absolute value of x plus 2. And an f of x equals 4 times the quantity x plus 2 squared minus 1.
The first one doesn't have an H.
It does not. Right. So let's start with what's our a? Negative 1/4. So what does that tell me is going to happen here? It's going to reflect across the x-axis. That's what the negative sign tells me. It is upside down. So it's going to be reflected across x-axis. We are being specific. Again, we're not going to have other reflections show up right now, but we will eventually, and so we're just going to be in the habit of being specific.
Isn't it also?
It is also going to be compressed. Because it's little and it's just so cute. I want to squish it. So it is also compressed. If you end up looking online for extra help, sometimes they'll say a number, like it'll be compressed by a factor of 4 in this case. So it's compressed by the number. But I'm not super specific about that. I don't care about that. If we can see compressed, it works for me. What is our h here? As I say, it's not going to be x. It's x minus h. So I don't have anything being added or subtracted here. So it's 0. So it doesn't have any transformation to it. It's not being shifted left or right. It's going to stay right in the center there. And then our k, what's our k here? 2. What's that mean? Up to. All right. Last one like this, and then I'm going to show you why we care. What's our a over here? 4. What's that mean is happening? Stretch. What's my h over here? -2. It's always that opposite sign. So what is happening there? Which way does it go? Left. And what's our k? -1. Which way does it go? Down. So it goes down 1 and the h goes left 2. Okay? I'm going to give us a... Okay. We are going to do one graph because I want us to see how this can help us in what we're doing. And then I'll pass over to Mike. I'm going to give you guys like single graphs. Some of them have a couple of numbers cut off because I was just a little close with the cutter. But you'll still get the vibe. So we're going to do one graph and this is it. All right. So this is the one we're going to do. It is not super duper complex. We've done worse ones than this yesterday. But I want to show you the way we're going to graph using A, H, and K. And again, this is the same process for all of the A's, H's, and K's for everything we do all year long, which is why we're going to hit this for so long. We're going to use this today, and we're going to talk about it tomorrow as well. But I wanted to have time so that our brains could process it through once. So our equation here is f of x equals the absolute value of x minus 3. We can do this. We did this yesterday, some very, very similar. But I want to start with figuring out our A, H, and K here. Just like we did before. What is our A on this graph? 1. What is our H on this graph? 3. Positive 3. Good. What is that transformation going to be? Which way is it going to move? Right 3. And what's our K? 0. There's nothing added on the end. So it's not going to be shifted up at all. So when we're making our tables here, doing this using our A, H, and K, I'm going to wind up writing 2 tables, but I kind of do them in a strange way. So I'm going to start in the middle. I'm going to pick my x's to find my y's. And we're going to put in here what's called our parent function. This is the very first one we did yesterday. The basicest of basic. No h, no k, no nothing. My y equals the absolute value of x. We did this one first yesterday. And I talked about how we would have our very new bestest friends that we write in our x column that we will use in most graphs, where we go from -2 to 2. That good view of the middle. Put our best friends in here. -2, -1, 0, 1, and 2. That good view of the middle. And since this is our absolute value, we know our y's. The absolute value of -2, +2. The absolute value of -1, +1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. We're not drawing that. We're using our parent function. Because what we're going to do is we are going to apply our transformations. The way I do it is I apply them to the outside. If you want to make two separate tables, that's totally fine. Some people like to go outside in, whatever works for your brain, and as you play around with it, you'll figure out what works for you. But the way that I do it is I take and I make a little spot outside over here and a little spot outside over here. So I'm making my table wider because I'm going to take my x values over here and I'm going to take my x and add my h value to it. So my h here is 3. I'm going to take my x's and I'm going to add 3. So -2 plus 3 is going to give me what? 1. -1 plus 3 is going to give me what? 2. 0 plus 3. 1 plus 3. 4. 2 plus 3. 5. On my y side, what we're going to do is we're going to take our y's times our a plus k. So in this case, I'm going times 1, which doesn't change anything, plus 0, which doesn't change anything. So it's going to be the exact same in this one. So my a is 1 means we don't actually multiply by really anything. K being 0, there's no transformation. So I'm just going to wind up with the exact same values. So we're going to wind up with 2, 1, 0, 1, 2. But when we have a's and k's, we apply them that same way. And this is a lot less calculation than we did yesterday. Because this is my completed table. When we're graphing it, my x's, my y's. So the point 1, 2 is my first point. So plotting it up, we're going to run out of time, but we're close. 1, 2, 2, 1, 3, 0, 4, 1, 5, 2. And we have our absolute value that is shaped like a V. Ooh, that was trash. It's shaped like a V. We have our point. And if we look at it compared to the ones we graphed yesterday, this has moved right from where it first started. It moved right 3. In fact, if we do it right, we should always wind up with our H right here and our K right here. Always. H and K will be that center point. Okay? This is how we're going to graph stuff pretty much from now on. Everything except lines, we're going to use this kind of table. So